Hey guys, so today we are starting one of my most favorite things in the whole entire world is integration by U substitution. Okay, now we used a U substitution when we were finding derivatives, which was the chain rule. So like say, remember we did say y equals x squared plus 3 all to the fourth power. When we were finding the derivative of that, we went to the side, chose our u, then u prime, and then f of u, and then f prime u. And that was the pattern that we used to find derivatives when we had a u substitution. And then u prime times f prime u was the derivative. So u prime times f prime u was our derivative. Actually, let me write that right here, okay? So that would simplify to 8x times x squared plus 3 all cubed. Okay, so that is the pattern you use when you're integrating or when you're taking your derivative using a u substitution. U prime, f of u, and f prime u. So I'm going to write both of those patterns out for derivatives, just because I want to show you how using the u substitution pattern for derivatives and the u substitution pattern for integration, how they each work. So for a derivative, you find your u and your u prime, then you identify the outer function, which is f of u, and then take the derivative of that. And the derivative is u prime times f prime u. For integrals, you will identify the u, but you're going to identify the derivative of u with respect to x, and then the derivative of u is going to be something here on that squiggle line, and then you're multiplying your dx over. So now it's on the other side, okay? So du will equal something in terms of dx. So for example, if we had this x squared plus 3 all to the fourth, okay? The u would be x squared plus 3. Du with respect to x would be 2x. And then du would equal 2x dx. Okay, that's the goal here, okay? So this now over here is the pattern of u that we are going to be using. Okay, so very basic example. And pay attention to what I tell you because it is going to make or break whether you understand this or not. We can make this really, really, really simple, or you can get completely lost. And from here on out, you will remain completely lost. So this u substitution is vital. Okay, so we're starting with example 1. So I'm going to show you my way of making sense out of this. We're using the examples from the book, but we are going to be using my reasoning, okay? So if you recall, when we first started integration, I said that there was like 5 patterns for derivatives and about 85 for integration, okay? So this is, other than the basic power rule, which we just used, this is the second easiest way to integrate, okay? We are going to pick our u. So we're going to come over to the side, and we are going to identify the u. The u is always that inner function. Okay? U is equal to x squared plus 1. The derivative of u with respect to x is 2x. Now we are going to swing the dx over, and this is the pivotal point of understanding right here. Okay? This dx that we have right here that we've solved for has to match the dx we've got in the problem. They have to be identical. If they're not, you will either divide something away, and I'll show you how to do that when we get there, or this is not the right way to integrate, and you've got to pick another method, okay? But for right now, the 2dx in the problem, matches the du. In other words, you'll hear me say the phrase, the dx's match, okay? This right here is identical to that right there. So, because that's true, and du is equal to this 2x dx, what we are actually integrating is u squared du, because our u is x squared plus 1, and that x squared plus 1 is being squared. So, in other words, to make this simple, all we have to worry about is integrating u squared using the basic power rule. U cubed over 3 plus c is the antiderivative. Now we'll put u back in as x squared plus 1 to the power of 3 over 3 plus c. Now we're done. So the whole goal is to match your dx's. Okay, let's look at another example. Example 2. The antiderivative of 5 cosine 5x dx. Okay, so what I want to do is eventually get you guys to rewrite this just by recognizing what your dx is going to be. For example, I know that my dx needs to be 5dx. Okay? So we'll go back up to the original problem, and our u is that 5x. Remember, if we've got something like cosine or sine or an e to a certain power, okay? If you've got anything other than a plain old ordinary, everyday, all by itself, boring old x, then it's a u. So this is not just cosine of x. That must mean that our u is 5x. So again, 5x is not a plain old ordinary, everyday, all by itself, boring old x. It's a 5x. Therefore, it is our u. So u is 5x. The derivative of that with respect to x is 5. So du is equal to 5 dx. And this dx matches that dx right there. Hence the reason for the rewrite. Okay? Eventually, you will be able to pick out what your dx is going to be by just looking at the problem. So I know now by going off of my dx, matching that dx there, and 5 dx is actually equal to du, what I am integrating is cosine of u du. The antiderivative of cosine is sine of u plus c. And I'll put the u back in and get sine of 5x plus c. And that is the antiderivative with the u substitution. Okay, so we will just continue moving on here. Okay, example 3. We have the antiderivative of x times x squared plus 1 all squared dx. Well, because I know that u has to be that inner function, I'm going to rewrite that and put my dx's together. Okay, so x squared plus 1 quantity squared times x dx. That's what I need to match once I pick out my u. So u is x squared plus 1. The derivative of that with respect to x is 2x. Therefore, du is equal to 2x dx. But notice, we have a 2 in front of our x dx, and the one in the problem does not. So what we need to do in order for our du to match x dx, we're going to divide away that 2. Now, let me tell you, you are allowed to divide away a number. You are never, ever allowed to divide away an x term. Only a number. Okay? So, 1/2 du now, our dx's match now that we have divided away the 2. That 1/2 will now go on the outside of the integral, and what we are integrating is u squared du. U squared, because that is our u right there, x squared plus 1, look over here, and what we're doing to that u is squaring it. So we are taking 1/2 times the antiderivative of u squared, and now our du, our dx is matched. So du is equal now to x dx with the 1/2 out front. So the antiderivative of u squared is u cubed over 3 plus c. Okay? So 1/2, multiplying those two denominators, I get 1/6. Okay, 2 times 3 right here. And then putting the u back in as x squared plus 1 cubed plus c. Okay, so sometimes we may have to manipulate our dx once we find that u and then du dx. We may have to manipulate the dx so it matches exactly what's in our problem. Most of the time, in order to match the dx's, you will be just dividing away a number, just like we did there. We divided away the 2 in order for our dx's to match. Moving along. Okay, I'm going to find one in the homework. So we have one more example before we investigate a change of variables. Okay, and then finally, we will also, I'll get there when we get there, sorry. Let's do, how about this? We'll do number 20 in the homework. Looks like this. Okay. Okay, that's number 20 from the homework. Okay, so what we're going to do is identify pre-writing or rewriting here. We're going to identify the u, okay? Well, the u has to be the inner function that is as an outer function squared, okay? So that is our u. That means that we can rewrite this as 1 over 1 plus x to the fourth all squared times x cubed dx. That is the dx now that we need to match from our u. So we have our u, du dx is equal to 4x cubed. Therefore, du is equal to 4x cubed dx. Now, our dx in our problem does not have a 4. So we are going to very nicely just divide away that 4. So 1/4 du is now x cubed dx. Now our dx's match as long as we're integrating with the 1/4 out front. So what we're integrating is 1 over u squared du. Because remember, x cubed dx there is equal to 1/4 du. The 1/4 is out there. So x cubed dx is equal to 1/4 out front du. Okay? Now, we do not have a pattern for integrating 1 over u squared. So we will rewrite it as u to the negative second and then integrate. 1/4 times, remember you're adding 1, so u to the negative first over negative 1 plus c. So the negative 1 in the denominator is going to come out in front of the 1/4. And then u is 1 plus x to the fourth, all to the negative first. Now, in order to rewrite that negative first to the power of a positive, is to just put it underneath. And now it is a positive 1 power plus c. Okay? So, integration by a u substitution, the most important thing is that you get your dx's to match. Okay, now we're going to back up here a little bit and learn about a change of variable. Again, it requires a little bit more work on our part, but as long as we can keep track of our stuff, then everything works out perfectly. Okay, for example, we're on example 4, change of variables. Okay, so we are integrating 2x minus 1. That's the square root of, so I just wrote it as a 1/2 power. Remember, you do not have an integration rule to integrate a square root, a cubed root, whatever. You have to write it with a power. So the square root of 2x minus 1 is the same thing as 2x minus 1 to the 1/2 power. So we're going to come over here and we are going to pick our u. And du dx equals 2, and du equals 2 dx. And actually, no, that does not require a change of variable. In the book it does, it actually does not, because for our dx's to match in our problem, all we need to do is divide away the 2. Now, the dx we get right here matches the dx in the problem. Okay, so we are integrating u to the 1/2 du. I don't know why they said this was a change of variable, because it's actually not. So u, yeah, okay. So the antiderivative of u to the 1/2, remember we're going to add 1, which is adding 2 over 2, would give us u to the 3/2 over 3/2. And that bottom 3/2 is going to come out front, flip upside down, and this is now what we have. Now all we have to do is put our u back in to finish it off. I don't know why they said that was a change of variable, because it is very definitely not. A change of variable. Wait a minute. Oh, I forgot to multiply the 1/2 out front. Sorry. I'm putting it back up in there, and I'm going to put it right here. So sorry. And I'm going to put it right here. Oops, I forgot to carry along my 1/2. That 1/2 du, that 1/2 needed to go out front, and I forgot to put it there. Okay, so now at the very end, the 2's are going to cancel. So what we're actually left with is 1/3 times 2x minus 1 to the 3/2 power plus c. Okay, don't forget to rewrite the integral with, if you've divided something away to get your dx's to match, don't forget to do that, because, duh, look what happens. It doesn't end well. Okay, now let's look for a real change of variable. Let's see if example 5 is actually a change of variable. So this is the problem right here. Okay, so if this inner thing is my u, then I would have to say that I'm going to rewrite this, and that is now my dx. That's what I need to worry about matching, okay? That's the dx I need to worry about matching. Okay, so here's where we actually have a change of variable. Pay attention. U equals 2x minus 1, no change there. Now, du dx is equal to 2, and du is equal to 2 dx. But even if we divide away the 1/2, look at what we get. We have a dx, and we needed to match an x dx. Oops. Okay, so here's where this is again now where you need to pay attention, because the dx's do not match. Okay, what we're going to do is we're going to go back up to the u equals and solve that for x. So if we solve that for x, we're going to add the 1 to both sides and then divide by 2. And that's what x is equal to. Now what we're going to do is we're going to go back into the problem, and everywhere we see an x, we're going to replace it with that. Okay, so 2 times u plus 1 all over 2 minus 1 all to the 1/2 times, here's another x, u plus 1 over 2 du. Okay? So it looks like, actually that's, and then the 1/2 would come out front. The 1/2 from over here would come out front. So du, this du right here is matching this dx right here. Okay, so the 1/2 goes out front, just like it always does. Okay, so let's recap quickly. when our dx's did not match, when our x dx did not match our dx, that's when we knew that we had to make some adjustments. When the dx's don't match, you need to make adjustments. So we go back up to the u equals equation and we solve that equation for x. Then we go back to the original and we rewrite the antiderivative with what x is equal to in terms of u. Now, when we look at that integral, before we actually integrate, there are some simplifications we can make. The 2's here divide away, and this 2 right here can be pulled out front and multiplied by the 1 that's already there. So now what we have is u plus 1 minus 1 to the 1/2 power times u plus 1 du. Okay? Now, we're going to simplify. Stay with me, stay with me. U plus 1 minus 1 is u to the 1/2. U plus 1 du. Now that everything is in terms of u, we can actually distribute in the u to the 1/2 because the power on that u is a 1, but we can rewrite it as 2/2. Now we can add the powers. Remember, when you are multiplying like bases, you add your exponents. So u to the 1/2 times u to the 2/2 is u to the 3/2 plus u to the 1/2 when we distribute all the way out. Now we can use our basic power rule. Okay? So the antiderivative of u to the 3/2 when we add 2/2 is going to be 2/5 u to the 5/2. And then when we add the 2/2 to the u to the 1/2, we're going to get 2/3 u to the 3/2 plus c. Remember, whatever we get as our power can come out front as a flipped fraction. Whatever we got as our new power can go out front as a flipped fraction. So now what we're going to do is distribute in the 1/4. So 1/4 times 2/5, the 2 cancels and the 4 divides away to a 2. We get 1/10, 2x minus 1 to the 5/2 power, plus when we multiply 1/4 in to the 2/3 right here, we'll get 1/6, because 2 goes into itself once and it goes into 4 twice. So 1/6 u to the 3/2 plus c. And that is when our dx's don't match. When your dx does not match the dx in the problem. Okay, let's do another one. Yikes. Okay, how about this? Okay, so I've got sine cubed of 3x, okay? So I'm going to actually pick my u. So in other words, sine cubed 3x is actually sine of 3x all cubed. That is a rewrite of sine cubed of 3x. So that means that that inner function there is my u. So what I need to be matching is that dx right there. And let's see if that happens. So u is equal to sine 3x. Now we need the derivative of that with respect to x. But remember, if that 3x is not a plain old ordinary, all everyday, all by itself, boring old x, then that is also a u. So we've got a u within a u here. So let's move our du dx down a little bit, and we'll go to a secondary u, which is 3x. U prime is 3. F of u is sine of u, and the derivative of sine is cosine. Okay, so u prime times f prime u is 3 cosine of 3x. And it looks like then that our dx's are going to match. So so now that we picked out the u, this right here is du dx. So du is equal to 3 cosine 3x dx. Now, look at the dx in our problem and the dx that we've got right here. The only difference is we need to divide away our 3 so our dx's match. Now our dx's match. So the 1/3 goes in front of the integral, and what we are actually integrating is u cubed with respect to u, or u cubed du. Okay? So the antiderivative of u cubed is u to the 4th over 4 plus c. So we can pull out the 1/4 and multiply the 4 by the 3, and u is sine of 3x, and that's all to the 4th power. So the rewrite of that could be sine to the 4th of 3x plus c. And actually, those parentheses are not needed, okay? And that is our antiderivative. Sine Okay, I just looked at example 6. Example 6 had sine squared of 3x, and I wrote sine cubed of 3x, okay? That's why my answer does not match what's in the book, because I wrote the problem with a power of 3 instead of a power of 2, okay? So my work is correct with my power of 3, okay? And our dx's match. Again, it's the method. All right, we didn't have another change of variable there, which is a little bit interesting. Let's see if we can find one in the homework. Okay. Let me look at that for just. Okay, I believe I found a decent example. We'll go through number 59. We've got x squared times the square root of 1 minus x, which is 1 minus x to the 1/2 dx. So I would rewrite that and put my dx together, because I know that 1 minus x has to be my u. So 1 minus x all to the 1/2 times x squared dx. So we're going to come over here and say u is 1 minus x. The derivative of u with respect to x is -1. So du is equal to negative dx. Okay, well, we're going to get rid of the negative just so we have a dx by itself. So negative du is equal to dx. So as far as the dx is concerned, that is a rewrite. In other words, negative du will replace dx, okay? Negative du, because dx is equal to negative du, will write negative du in place of dx. Now, because our dx was a dx and what we needed in the problem was x squared dx, our dx's don't match. Okay, so what we need to do about that is, I'm going to move that over here a little bit. Okay, what we need to do about that is go back up to our u equation, and we are going to solve that equation for x. So u minus 1 is equal to negative x. Therefore, that's those three little dots there. Therefore, 1 minus u is equal to positive x. So I'm going to go back to my problem, and 1 minus u is going to be filled in for every x I've got in my problem. So this x squared is going to be replaced with 1 minus u squared. And then in our 1 minus x here, 1 minus u to the 1/2. Okay, so now we've made a replacement, our dx. So everything needs a replacement. The dx needs a replacement, that x needs a replacement, and that x needs a replacement. Okay, the dx we found right there. Dx is equal to negative du. Therefore, we put our negative du in place for x. Then we have an x squared. If x is equal to 1 minus u, x squared is replaced with 1 minus u all squared. And then continuing on to the left, 1 minus x is replaced with 1 minus u. Okay, now we can do some simplifying. 1 minus u is like 1 minus 1 plus u, all to the 1/2. Remember, we have to distribute the negative. So 1 minus 1 is completely gone, and what we're left with is just u to the 1/2. Okay? And then we've got 1 minus u squared. So we need to distribute that, and we'll get to that in the next step. Okay? So 1 minus u all squared is 1 minus 2u plus u squared. And then the negative by the du is going to come out front. And there we go. Now, what we're going to do is distribute the u to the 1/2 in. U to the 1/2 times 1. Let's start at the beginning, right there. Okay. U to the 1/2 times 1 is u to the 1/2. And then we'll go there out. Remember that u is the same thing as to the power of 2/2. Okay. So u to the 1/2 times negative 2u to the 2/2 is minus 2u to the 3/2 power. 1/2 plus 2/2 is 3/2. And then we'll go out to the farthest. Now u squared is the same thing as 4/2. because 4 divided by 2 is 2, and we started with a u squared. So u to the 1/2 times u to the 4/2, 1/2 plus 4/2 is 5/2. Now we integrate. The antiderivative of u to the 1/2 is 2/3 u to the 3/2 minus 2 times the antiderivative of u to the 3/2 is 2/5 u to the 5/2, and the antiderivative of u to the 5/2 is 2/7 u to the 7/2 plus c. Now what we're going to do is distribute the negative out front, do some simplification on the inside of the parentheses, and then substitute what u is equal to back in. So, negative 2/3 1 minus x to the 3/2 plus 4/5 times 1 minus x to the 5/2 minus 2/7 1 minus x to the 7/2 plus c. And that is your antiderivative. And we have run out of time for today, but we'll do more in this section. So you will have a little bit of homework here. Then we'll do more in this section for the lesson on Tuesday. Okay,